This is section 1.5. I'm going to do a couple more examples with compound inequalities. I didn't get much feedback or any questions from the first round, so I'm not quite sure how that went. So I just thought I'd do 2 quick problems to review what you did the other day. So a compound inequality, you'll see, is 2 inequalities joined with the and or the or. So you go ahead and you solve each one separately, and then when you're done, you're going to make a number line. All right, so let's go ahead and get started. Example number 1, we have 3x greater than or equal to negative 12 and 5x less than or equal to 5. So again, like I said, first thing you're going to do is just go ahead and solve each inequality. So my first one here, we are going to divide both sides by 3. And we have x greater than or equal to a negative 4. All right, then we go ahead and we solve the other one. So 5 times x, so 5 times x means I'd go ahead and divide both sides by 5. All right, we have x less than or equal to 1. All right, now our last step is to go ahead and make our number line and shade to show all the possible solutions to this compound inequality. So I'm going to go ahead, we're going to make a number line, we're going to put our key numbers on there. All right, so let's say we have 0 there, negative 1, negative 2, negative 3, negative 4 will be there, positive 1 over there. All right, so the first thing you want to do is decide whether or not you should make a solid dot or an open dot at the key points. And since this problem, it says greater than or equal to, then it says less than or equal to. For both of these, we can have solid dots. So I'm going to go ahead and do that. I'm going to put my solid dot here at the 1. I'm going to put my solid dot right here at the negative 4. All right. And then if you go back and look at the inequalities, think which way you would have to shade each one kind of individually. This one, first one says x is greater than the negative 4. So this is where my negative 4 is. Greater than would be going this way. All right. If I look at the other inequality, it says x is less than 1. So if I was thinking of shading that one, less than 1 would go this way. Okay. So for an and problem, it has to satisfy both. So it has to be greater than the negative 4 and less than the 1. So in the and compound inequality, your number line usually looks like this, in which you have that shaded section of the number line kind of between your two solutions. You can always check to see if you shaded the right part of the number line. Anything in that shaded section, if I take that number and plug it into both inequalities, it should be a true inequality. So for example, in this one, 0 would be a pretty easy number to choose and check. 0 is in my shaded section, so that means it should be a solution. If I take 0 and put it in here, 3 times 0 is 0. Okay, and 0 is greater than or equal to negative 12. All right, if I take my 0 and put it into my other inequality, 5 times 0 would be 0. And 0 is less than or equal to negative 5. So if you're unsure on whether or not you shaded the right part of the number line, again, you can always do that quick little check. The shaded part, any answer in that shaded part needs to work in both inequalities. All right. And second equation, or second example, this one you can see is an or. So we have 7x less than or equal to negative 28, or 2x greater than negative 2. All right, so just like before, you're just going to start off first of all by solving each inequality. So on this side, I'm going to divide both sides by 7. All right, we have x less than or equal to negative 4. All right, for my other inequality, we're going to divide both sides by 2. We have x greater than negative 1. All right, so now we're going to go ahead, we're going to make our number line. All right, so let's see, we'll put 0 there, negative 1, negative 2, negative 3, negative 4 would be there. All right, Since the -4, if we look at the inequality, it says x less than or equal to. So at the -4, I can put a solid dot. On the other side, where it says x greater than -1, okay, it does not say equal to. So since it just says greater, that means I have to have an open circle here, okay? I can't really use 1, but I can use anything greater than 1, okay? That's what the open circle represents. All right. Now, for the or, your number line is going to look a little different. So if we take a look, this is x less than or equal to. So if it's less than or equal to, we would shade everything going this way. All right. On the other inequality, it says x greater than. Greater than means that we would shade that way. Okay. And your problem looks like that. So again, for the and, like I said, it usually ends up to be a chunk in between your two solutions. For the or, usually one's going to the right and one's going to the left. Now there are some weird things that happen sometimes, especially when you're working with negative numbers and dividing by negative numbers, but typically those are what your solution should look like. All right, there you go. Good luck.